Okay, here I am again. So today we're talking about general antiderivatives and slope fields. You have been working with antiderivatives all last unit because we used them to evaluate integrals that were definite. And so we had endpoints on that. So today we're going to talk about what an indefinite integral is, and an indefinite integral doesn't have an a and a b there. So in an indefinite integral, it's going to be the set of all the antiderivatives of the function. You're going to see it written like this way. Okay, well, what's the set of all antiderivatives? What that means is that all antiderivatives are going to differ by a constant that comes up on your homework today. I don't know if you remember me talking about this. In fundamental theorem of calculus, the constant didn't matter because we went backwards and then we went forwards again. And so when we did that, we were basically taking the constant and subtracting it off because we were doing that constant on both top and bottom of the endpoints. But today, in general, we have to keep in mind that when we're trying to find an antiderivative, we are going to need to denote that there's a constant on the end by adding a plus c to the end. Furthermore, I'll give you some points that will allow you to find c in some instances. Okay, what do I mean by that? So I mean, let's say I had x squared plus 8, and I took the derivative. That's just 2x. Well, if I started with 2x and said, hey, what did this used to be? And you would tell me, you guys would say, hey, that was x squared. But how do I know that there's not a constant there? Because the derivative of constant is 0. And it didn't matter when we were doing definite integrals, but now it matters when it's in general. So we are going to make sure, and you see here, I wrote our integral rules again. Okay. Just make sure you're using this. If something on your homework is unfamiliar, go back to this list. You might be forgetting, like maybe your arcsine shows up, I think, today. I think arctan shows up on your homework today. Natural log, where are you? Natural log shows up, so just be careful of that. But for all those indefinite integrals, we're going to attach a plus c. Okay, so I have kind of some loaded examples here where we get a little mix of everything. All right, so antiderivative of negative x to the negative third. This is power rule. I'm going to add the 1 back on. That's negative x to the negative 2 divided by negative 2. The cubed root of x is the same thing as x to 1/3. So I'm going to add that power back on. That's x to the 4/3 divided by 4/3. I'm going to have to clean that up in a second. Minus 1. What's the antiderivative of 1? It's just x. And then e to the 3x. Well, e to the x is just e to the 3x. I want you to think about this a little bit, though. If you were doing the derivative of e to the 3x, because that's how you kind of check your answer, you take the derivative of this, and that's going to give you that. You would have a 3 in front because of chain rule, but there's no 3 there. So I'm going to divide by 3. We're going to hit this really hard next week. Okay, let's see if we can simplify this a little bit. Those negatives cancel. You could write it as a fraction, but it was given to me as a negative exponent, so I think I'm just going to leave it as x to the negative 2 over 2. This I should definitely clean up. This divided by 4/3 is the same thing as 3/4 x to the 4/3 minus x plus e to the 3x over 3. And then this is where I need to double check. I need to make sure it's possible there's some constant or some number behind that. If you want to check your answer and see if it's right, you can go back to the original, okay? And if you go back to you take the derivative of this, and if you don't get that, then you did something wrong. Okay, let's try another one. The antiderivative of 3 sine would be 3 cosine of x. The antiderivative of minus sine 3x, okay, well, how do I handle that? Okay, talk about that in a second. Not quite done yet. So going forwards, all right, 3 cosine, if I took the derivative of that, my apologies, antiderivative of sine, I got to go backwards, silly me. That should have been negative, right? Should have been negative. This should have been positive. All right. Negative 3 cosine, I go backwards, that would be negative 3 times negative sine. That's good. This one, negative sine 3x times 3. Oops, there's no 3 there. Got to divide that by 3, and then plus our constant. If you're feeling a little suspicious of this guy and this guy right here, don't be super concerned about this. We're going to really solidify that next week. All right, so really, you guys have been doing antiderivatives all along, so I'm not too concerned about that part. It's going to give you some more practice today doing that. Where we use this now is we use this in something called differential equations. A differential equation is an equation containing a derivative, and so you're going to see it's going to be written like in the form dy dx, or maybe some other variable, okay? Just like in algebra, when you want to solve an equation, you're going to use inverse operations. But to undo a derivative, we are going to take an antiderivative, aka or an integral. You'll see me use the integral symbol. Recall that a function can have many derivatives, all of which vary by a constant. So we're going to need to then put a constant in here. Okay, so I'm going to show you this just when you don't have 2 variables, just when you have 1. And then I might have to show you one more that has 2 in it. So solving a differential equation is going to involve a unique equation that satisfies some initial conditions. So you're going to be provided with some values that allow you to find the constant. The order of a differential equation is the order of the highest derivative involved in the equation. All right, let's take a look. So in this particular we're going to use integrals to do it, but I'm given dy dx equals sine of x. So it says by separation of variables. So what I'm going to do is I am going to go ahead and I am going to keep dy over here. I need my dx to be with my sine x. So I'm going to multiply both sides by dx. Next step, I'm going to undo the dyx, this is what I was talking about, by taking the integral of both sides. The antiderivative of dy is just y. And then, I know this seems kind of like, what? Why can't I just do the antiderivative? Okay, yeah, I get that. But in a couple minutes, you're going to see sometimes I don't have just an x here, I have an x and a y. So. And then what's the antiderivative of sine? And you would all tell me, okay, that is negative cosine plus a constant. Hey, we just did one like this. Okay. But before we stop, now I have this value and I am going to plug that in, okay? So if y of 0 equals 2, so that means I'm going to plug 0 in for x and 2 in for y. And be careful with cosine because you want to think, oh, it's 0, but the cosine at 0 is 1. I add my 1 to the other side, c equals 3. And so that means my specific equation is negative cosine of x plus 3. Okay, tomorrow we're going to look at the graphical look at differential equations. And then maybe a little separation of variables on that. Okay, so that's where we're going to stop for today. That should give you enough to complete today's homework.